Hi ladies, this is a continuation lesson of 6.4, and in this part of the video we're going to look at graphing the inverse function. So we're going to find the inverse function with a set domain, and then we're going to graph the function and we're going to graph the inverse of the function. We're going to look at the relationship there. So if you remember from the last video, inverse relations, we switch the x and the y values, and if the inverse and the relation are functions, then we have an inverse function. So let's look at example 3 on your note sheet. And in this example, we're finding the inverse of a power function. So again, to find the inverse, we have to switch the x and the y values, or we have to switch the input and the output values. So we're finding the inverse of f of x equals 4x squared, and a stipulation we have is that x is greater than or equal to 0. That's our domain restriction. So first of all, if you look at those two tables, function f, if we plug in a few x values, 0, 1, and 2, we get the output, we get the coordinates 0, 0, 1, 4, and 2, 16. Now for the inverse function, we're switching those x and y values. So every y value becomes an x value, and every x value becomes a y value in the inverse. But actually, we're being asked to find the inverse function, so we need to switch the x and the y values in the equation. So when we're finding the inverse function, right now we have y equals 4x squared for f of x. So the inverse of the function is x equals 4y squared. And we need to solve for y. So we're going to divide both sides by 4. We get x over 4 equals y squared. And then we have the square root of both sides. So we have the square root of x over 4 equals y, and that is our inverse function. Now, if you think of the properties of radicals, we can't have a radical in the denominator. So this is written the same as the square root of x over the square root of 4, which is y, which is the inverse of x, or the inverse of f. So we have now the square root of x over 2. That is our inverse function. So now we need to graph these two functions. So I've already, and we can just double check for the inverse function, our coordinates. So again, our inverse function of x, we've got x and y. We're going to substitute x values in, and let's start with 0 because our domain says that it has to be greater than or equal to 0. So 0 over 2 is 0. And then looking here, the next value we used was 4. So 4, the square root of 4 over 2 is 2 over 2, which is 1. And then 16, the square root of 16 over 2, which is 4 over 2, which is 2. Okay, so now let's graph the inverse function and our original function. So I'm going to graph the inverse function in purple. 0, 0, 4, 1, and then way over here, 16, 2. So in my domain, again, it starts at 0. That's my restriction. So I'm not going to graph anything less than 0 for my x values. Now I'm going to graph my original function. I'm going to do that in black. So 0, 0, 1, 4, and 2, 16, which is way up here. And my graph for that is going to curve out a little bit and go way up. So when we're checking our solution, note that the graph of our inverse function, which is the square root of x over 2, or 1/2 times the square root of x, that's the reflection of the graph of our original. So the inverse of the function, 1/2 the square root of x, is the reflection of the graph. The original function, f of x, equals 4x squared, where x is, this should say greater than or equal to 0. And it's over the line y equals x. So if we just sketch in our line y equals x here, and you can see that this is a reflection over that green line. So that's a good way to check your inverse solution. You can also do the horizontal line test to check whether or not it's a function. So if you're just graphing the inverse function, so if you remember, the vertical line test was to test whether or not function relation was a function. So we're going to use the vertical line test for f of x. And we're going to use a horizontal line test for the inverse of x. So if a horizontal line does not intersect the graph in more than one place, then the inverse is a function. So if this is the inverse, we're looking at any horizontal line and it does not intersect our graph in more than one place, this is a function. Right here, as you can see, it intersects nowhere. So now let's look at another one. And actually on your note sheets, we'll look at the one that's on your note sheets. Finding the inverse of a cubic function. So consider f of x equals 1/4 x cubed plus 3. We want to determine whether the inverse of f is a function, and then we're going to find the inverse. So first I'm going to define some coordinates for my function, and then I'm going to graph those coordinates. So you can see those coordinates on the left of the screen. And I just use substitution, so just substitute a few values for x in and not my y values. So once I have my coordinates, I can graph my function. And then I'm going to perform a horizontal line test to see whether or not this relation is a function, if the inverse of this relation is a function. So any horizontal line I draw across this graph is going to only intersect the graph at one place. That means that the inverse is a function. So now we just need to find the inverse of f of in the inverse function of f of x. So in order to find the inverse of x, I'm going to switch around my x and my y's. So my inverse of x is my new y. But I'm going to switch that around with my x value. So here's my inverse function, and now I need to solve for y. So I have x equals 1/4 y cubed plus 3. I need to isolate my variable. So I'm going to subtract 3 from both sides. And I get x minus 3 equals 1/4 y cubed. Now I need to multiply both sides by 4. And I need to take the cubed root of both sides in order to solve for y. So I have the cubed root of 4x minus 12 using the distributive property equals y, which is the inverse of my function x. I can't simplify 4x. There's no perfect cubes as factors. I can't simplify 12. There are no perfect cubes as factors. So this is my final answer, my inverse function. And you can substitute x values in, and you will get the y values that we got when we switch the inverse, or when we switch the x and the y values with our original function. Right now, there are 2 more examples on this note sheet, so please try those next 2 on your own, and then you can unpause for the solution. So please pause while you work, and unpause for the solution. Okay, so our inverse function here is the 4th root of 8 times x minus 1. All divided by 2. Remember that you have to rationalize your denominator. So we did have the 4th root of x minus 1 over 2 equals y, or equals our inverse function, but we need to rationalize that denominator. So we have to multiply by 1 in the form of the 4th root of 2 cubed in order to get our denominator to be a perfect 4th root, so that we do not have a radical in the denominator. Right, then there is one more. So please try this one on your own and pause the video while you work, and then you can unpause for the solution. You're looking for the inverse of the function. So here we're looking for the inverse. So the inverse of g of x is 2 times the 5th root of x. You have to remember that the 5th root of 32 is 2. So we can rewrite 32 as 2 to the 5th power. And so the 5th root of 2 to the 5th power is just 2. So please jot down any questions you have, and we can go over them in class. Thank you.